So in this problem is basically based on the wave motion. So they are given a transverse wave. That wave representation is y is equal to 2 sine omega t minus kx, that is expressed in centimeter. So we have to find out value of wavelength, right? We have to find out value of wavelength for this wave equation, for this wave representation, right? So at what condition the wave velocity supposed to be equal to the maximum particle velocity. So at that condition we have to find out the wavelength of this wave expression. So we are given some wave expression. For that wave expression we have to find out what is the wavelength. Okay, the lambda we have to find out. So the condition is the wave velocity becomes equal to the maximum particle velocity. So that is the problem statement. So basically we have to find out the lambda for this wave expression. So they are given 4 options, right? 4 pi, 2 pi and pi and 2. So this is the 4 options. We will solve it and then find out what is the right answer. Okay. So for this what we will do to calculate or to solve this, we will write the maximum velocity of the particle. Maximum velocity or particle velocity, right? Maximum particle velocity I will express as the following, right? So maximum particle velocity I call it as Vm. So that is equal to wave amplitude, maximum wave amplitude into the angular frequency of the waves, right? So basically for what condition we have to find out wavelength. So the maximum particle velocity, right? When the condition is maximum particle velocity, so we have to find out what is the wavelength, right? So wavelength. So therefore maximum particle velocity can be calculated using this relation, that is Vm is equal to A into W. So here Vm is the maximum particle velocity, A is the that wave's amplitude, maximum amplitude, omega is the angular frequency. So we also know, as we know that the wave velocity, right? So the wave velocity relation is the following: wave velocity, the wave velocity relation we can write it as I will write it as Vp, which is equal to omega by k. This is the wave velocity expression. So this is the wave velocity expression. Vp is the wave velocity, omega is the angular frequency, and k is the wave vector. So now what we will do? So the condition is we have to find out the wavelength when the wave velocity equal to maximum particle velocity. So wave velocity is equal to maximum particle velocity. So if it is equal, then we have to find out the lambda. That means Vm supposed to be, or Vp supposed to be equal to Vm, right? That means maximum particle velocity equal to the wave velocity. So in that condition we have to find out the wavelength of this expression. Okay. So therefore what we will do? So we know Vp and Vm. Now we can write it as Vp is equal to omega by k, which is equal to A Vm, right? Vm is equal to A times omega. Now what we will do? We can cancel the common terms. So that is omega will be cancelled. So k can be, okay, I will write it as, I will write here. So then what we have, 1 by k is equal to A. So this can be again written as k is equal to 1 by A. K is equal to 1 by A. And so we know k value, right? K is equal to wave vector. Wave vector is equal to 2 pi by lambda, right? So therefore instead of k I will write its expression, that is 2 pi by lambda, which is equal to 1 by a, right? So that is the 2 pi by lambda is equal to 1 by a, we got it. So basically we want to calculate the wave velocity, wavelength, so that is this parameter, right? Therefore what I will do, I will keep lambda, so therefore remaining terms I will bring it to one side. So therefore what I will get, lambda is equal to 2 pi, right? 2 pi into a, right? 2 pi into a. So now we will come to the expression, the wave expression, that is this. So in this expression, so this is y is equal to general wave expression is the general wave expression is what? So I will write here, the general wave expression is equal to y is equal to a sine, right? A sine omega t minus kx minus omega t, right? Kx minus omega t. So this is the general wave expression. So we can now take the value from this expression, right? So that means the a value, we will take it from this expression. The a value is 2 now. This is a general expression, wave expression. So if you look at here, the a value is the coefficient of sine term. The coefficient of sine term is 2 now. So that is our a value. I will substitute here. So that will give me the relation, the following relation. That is 2 pi by 2 pi into a is 2. Therefore, I will get 4 pi. So that means the wavelength is 4 pi. So if you go to the given 4 option and look at which is the right answer, so that basically 4 pi is the right answer. Okay. So I just recollect this, what we have derived or what we have solved it. So there is a transverse wave, right? That transverse wave expression is y is equal to 2 into sine omega t minus kx. That is the transverse wave expression. So for this wave, there will be some wavelength, right? So there is a wavelength. So that we have to calculate. The wavelength of this expression we have to calculate. So for which condition, when the wave velocity, that is omega Vp, is equal to maximum particle velocity. The maximum particle velocity is Vm and the wave velocity is Vp. When these are equal, if these velocities are equal, that is maximum particle velocity is equal to the wave velocity, so in that condition we have to find out what is the lambda for this expression or the wave velocity for wavelength for this expression. So that's what we have done here. So therefore the right answer is 4 pi.